Today's vodcast, V51, is about sampling. It starts on slide 54 and goes through slide 81. So to start off with sampling, let's take a look at an example. If we have a task to count the number of whales in the ocean or squirrels in a park, how could we do this and what problems would we face? Well, the ocean's really big and parks can be too. So it would be hard to count all of the animals because it'd be hard to cover all that space. In addition, animals can move, so it's hard to know which ones you've counted already. So, what can we use to help us with this? Well, let's look at some vocabulary first. So, a sample is used to make a prediction about an event or gain information about a population. The whole group, like the whole amount of squirrels in the park or whales in the ocean, is the population. But a part of the group is called a sample. So a sample is random or unbiased when every sample is the same size and has an equal chance of being selected. If a sample's biased, then the information may not be reliable. So for example, if you wanted to know how people in New York felt about mass transit, if you asked people at a train station, would that be random? Would that be unbiased? I would say no, because if they're in a train station, obviously they either enjoy mass transit or that's the best option for them. This would not be the best way to get a random sample. And that's what PMI says as well. It only includes people who take the train. It doesn't include people who walk, drive, or bike. Here's another example. Is this an example of a random sample? You want to find out about music preferences of people living in your area. You and your friends survey every 10th person who enters the mall. I would say this is random because we're surveying every 10th person. We're not picking who we want. It's just a random person. And the mall is a place where you could get lots of different people who like different music. It's not a country music store where most likely people would only like country music. It's a mall that serves all kinds of people. So let's take a look at what PMI has to say. They say, yes, the situation would produce a random sample. So please write that on your slide. On slide 58, we have an example about food services at a school. They want to conduct a survey by asking the first 20 students that enter the cafeteria lunch line to determine if the students are interested in hot lunch. Is this reliable? Well, here's what's really important. They're asking the first people who get into the lunch line. Now, if you think about our lunch line, no one goes in line to buy lunch unless they're actually buying lunch. So, of course, these people are interested in hot lunch. You would have to ask the people in the other parts of the cafeteria to get a random sample. So here, our answer is no. It is not a reliable survey. Our next question asks about guidance counselors organizing a career day. If they survey all the students whose ID numbers end in a 7, would that be random? Well, the ID numbers are completely random. So if you just pick the ones that end in a 7, that would give you a good population. It would most likely get you a random number of boys and girls, and it would go across all grade levels. So in this case, yes, this would produce a random sample. Please try slide 60 on your own. We're going to skip slide 61 and move right to 62, which just reminds us that the whole group is the population and the part of the group is a sample. So we're going to take a look at an example with wolves. And when biologists study wolves, they choose a sample, just a part of all the population of wolves that live on the mountain. So we're going to introduce you to something that biologists use called the capture-recapture method. And the next couple of slides all look pretty similar, so make sure to look at the number up in the top corner so that you can follow along. So we're looking at all the wolves on the mountain here. Obviously, they don't look like this. They're not close together. Otherwise, this would be much easier. So we're looking at a big group of wolves, which is also called a population. So the first thing that the biologists are going to do is they're going to find some wolves and tag them. So here we've tagged 8 wolves. That was the capture part. Now they're going to let them go, and they're going to intermingle themselves with all the rest of the wolves on the mountain. So you see we have our tagged wolves among all the other untagged wolves. Now we're going to recapture some wolves. So we took this group of wolves here, and we're going to count how many are tagged out of the total number that we captured. From here, we're going to set up a proportion and solve. So the words that we're going to use to help us are tagged over total. And we're going to look at what we did first and then what we captured the second time. So this is the first capture here. We first captured 8 wolves and tagged them. Out of how many in the total population, that's what we don't know. So that's going to be the variable. Then on the other side of the proportion, when we recaptured the group of wolves, we recaptured 9 total wolves and only 2 of them were tagged. So if 2 out of those 9 were tagged, we use this proportion to figure out how many about are in total if we tagged 8 of the total. So we solve this by cross multiplying. So 2W equals 72. Divide by both sides, but divide by 2 on both sides, and you get 36 wolves on the mountain, and that represents your population, your total amount of wolves. So let's look at another one. We have fish now, and 27 fish are captured and tagged, and they're released. Later, we catch 45 fish total, and 7 are tagged. So we want to estimate what the fish population is in the creek. So we're going to set up a proportion. Here's our key that we're going to keep using, tagged over total. So initially we tagged 27 fish out of the total number of fish that we don't know. Then later we captured 45 fish total and 7 of them were tagged. So solving this proportion, we get 7F equals 45 times 27, which gives us 1,215. We divide by 7 on both sides, and we get F equals 173 and 57 hundredths. But we're talking about fish here, so we want to round to the nearest whole number, which in this case is 174 fish in total in the river. Let's look at another example. Now we're not talking about capturing and recapturing animals anymore. We're talking about voters. So 315 out of 600 people voted for candidate A. How many votes could you expect in a town with a population of 1,500? So instead of using tagged over total, we still want total as our denominator, but we're going to use the sample for the numerator. So our sample here is 315 out of 600. So we set up a proportion. 315 out of 600 equals, we don't know how many, out of 1,500. When we cross multiply, we get 600x equals 1,500 times 315, which gives us 472,500. When we solve for x, we get 787.5, but we can't have part of a person, so we round up to 788 votes. And that's our final answer. We're going to skip slide 70 and go right to slide 71. For slide 71, again, it's not animals. We're looking at tires this time. So 6 out of 150 tires need to be realigned. How many out of 12,000 will need to be realigned? So we set it up using the sample, So the sample out of the total, 6 out of 150, equals x out of 12,000. When we cross multiply, we get 150x equals 12,000, not 12,000, 72,000, and x equals 480 tires. Please try slide 72 on your own. And then you're going to skip slide 73. In this example, we have a table to work with. So we're going to set this up a little differently, and this you can do with all of the problems as well. We have a chart that gives us a lot of information, but what we want to know is how many people we think are going to be wearing high-top sneakers. So we're going to use this chart as a sample. So we want to know how many high tops out of the total number of people. And our population that we're looking at is 300. But this chart doesn't represent 300. To figure out the total for this chart, we have to add up the number of students. So if 12 wear low tops, 7 wear high tops, 3 wear sandals, 6 wear boots, how many people are there altogether in that population? Well, there are 28 people. All of these numbers added together give you 28. And out of those 28, 7 are wearing high tops. So we set up our proportion. 7 out of 28 equals, we don't know how many, out of 300 total. Cross multiply to get 28x equals 2100, and we find that we get 75 high top sneakers. We're going to skip slide 75. This example asks us to make inferences about the results based off of a sample. So the student council surveyed people to see what lunch was the most popular, and they conducted 2 surveys on 2 random samples of 100 students. Here's the first sample, 12 hamburgers, 14 tacos, 74 pizza with a total of 100. The second one said 12 hamburgers, 11 tacos, and 77 pizza, also with a total of 100. So based on these 2 samples, what can you say? Well, we can definitely say that pizza was the most popular, and it was so popular that more students preferred pizza than hamburgers and tacos combined. These are the inferences that we're making based off of the samples. Here's another set of 2 samples about drivers in New Jersey. I said my inference from this chart was that the motorcycles were the least popular. Only 8 people here and 10 people here. I want you to make at least one more inference based on this data. So I said the fact about the motorcycles. You find something else that you can inference from this data. Our last few problems are going to surround themselves around this chart. So the student council asks people about potato chips to sell at the next basketball game. They took 2 different samples, and they surveyed about regular barbecue and cheddar potato chips. You're going to use this chart to solve the next 3 problems. I'll get you started on this one, but then the rest is on your own. So the first question asks, how many students participated in each survey? Well, look at them based on the sample. So here's the first sample. If 8 picked regular, 10 picked barbecue, 7 picked cheddar, how many people were interviewed all together? And the same thing for student sample 2. They may be the same, they may be different. Give this a try on your own. To finish up, you're going to try slides 80 and 81 on your own. So here's slide 80. 81, just make sure that you go back. The original problem tells you how many spectators they're expecting, and that's 250. So for 81, you want to use the first sample, this one, to see how many packages of cheddar potato chips you would need for the 250 spectators. This is your sample. You're using that along with this information to estimate. You're going to try that on your own, and you're also going to draw a sun on this slide to celebrate the beautiful weather that we should be expecting now that it's spring.